Have you ever looked up at the stars and wondered if the cosmos is playing tricks on us? This evening, we are diving into a mind-bending event right next door in our cosmic neighborhood that has the entire astrophysics community scrambling, forcing experts to completely rethink their foundational assumptions regarding the true nature of what our telescopes are truly capturing in the deep void. Back in August of 2025, researchers aimed the James Webb Space Telescope, the absolute pinnacle of human observational engineering, deep into the cosmic dark and struck cosmic gold. They spotted an exoplanet gracefully circling Alpha Centauri A, and this was not just your run-of-the-mill rock, but a massive, swirling gaseous globe, comparable in bulk to Saturn, dancing around the closest sun-like furnace to Earth. Scientists were ready to pop champagne. It felt like the crowning achievement of modern astronomy. Finding a genuine world tethered to the star system right across our galactic street, sitting merely a fraction over 4 light years from home, meant humanity finally had a tangible, reachable destination for future generations. Yet, before the ink could dry on the academic papers, the unthinkable occurred. The entire celestial body simply vanished without a trace. By the time this video concludes, you will grasp exactly why this initial triumph, followed by such a ghostly disappearing trick, stands as the ultimate puzzle of modern space exploration, proving just how profoundly ignorant we remain regarding the uncharted territories hovering right on our celestial doorstep. Just before we launch into this cosmic detective story, if your mind races at the thought of unraveling the universe's greatest riddles, please hit that like button and subscribe to our journey. It takes only a moment, but it heavily powers our algorithms, allowing these cosmic tales to find their way to fellow space enthusiasts across the globe. All right, let us ignite the engines. To fully grasp this enigma, we cannot simply begin in 2025. We must rewind billions of years to a majestic, gravitationally locked trio of suns known collectively as Alpha Centauri. This particular cluster holds a unique place in our scientific hearts for one primary motive: sheer proximity. Hovering a mere 4.3 light-years from our own solar backyard, it proudly holds the title of humanity's closest stellar neighbor. If you find yourself gazing skyward from below the equator, this system shines as a brilliantly dominant beacon in the dark. While your unprotected eyes perceive it as a solitary piercing dot, it is fundamentally a triad of blazing spheres, endlessly spinning in an intricate magnetic waltz that has endured since the dawn of the cosmos. The heavyweight champion of this trio is Alpha Centauri A, a radiant giant, just a hair heavier and more luminous than our very own sun. Its partner, Alpha Centauri B, is the smaller sibling, packing about 85% of our sun's total bulk. Together, they sweep through space in an oval-shaped racetrack, squeezing as close as 11 times the spatial gap separating Earth from the sun during tight passes, before swinging out to a massive 36 times that same gap at their widest stretch. Floating way out on the fringes is Proxima Centauri, a faint crimson dwarf star tracing a colossal distant loop around the central duo, separated by an astonishing 13,000 times the distance between our home planet and its star. Given its outermost track, Proxima holds the crown as the absolute nearest individual star to Earth, earning its literal title. However, the heart of our mystery lies squarely with the larger sun, Alpha Centauri A. For countless decades, the scientific community has harbored a deep obsession with pinpointing exoplanets within this neighboring system. The reasoning behind this fixation is incredibly practical. Should humanity ever evolve into an interstellar species, launching robotic emissaries or human pioneers into the great unknown, this specific cluster serves as the absolute, undeniable starting line. The spatial gap is just narrow enough that a voyage, though requiring lifetimes or even centuries with the engines of today, remains within the realm of physical possibility. Imagine a spacecraft rocketing outward at a mere 1% of light speed. It would touch down in roughly 430 years. That represents a massive generational commitment. Yet it is a highly quantifiable finite timeline. The math checks out. We could hurl a physical object across the void right now and guarantee it eventually hits its mark. Could we actually reach another star system within just 2 or 3 human lifetimes? Look at our other stellar neighbors for perspective. Barnard's star sits roughly 6 light-years out. Then there is Wolf 359, located 7.8 light-years into the void. In the cosmic ocean, every single extra light-year tacks on hundreds or even thousands of years to our travel time. That is exactly why Alpha Centauri is so magnificent. Its incredible closeness crowns it as humanity's undisputed stepping stone into the deep universe. But stepping into the cosmic unknown comes with a huge catch. You really need to scout the territory before launching a mission across the galaxy. Are there actual worlds orbiting out there? If so, what do they look like? Could any of these alien worlds harbor oceans, atmospheres, or even life itself? Shooting a multi-billion-dollar probe across the cosmic dark, only to find a barren, empty wasteland, would be an unimaginable drain on our time and resources. Because of this massive risk, for the last 20 to 30 years, stargazers have been obsessed with solving one major mystery. Do planets actually orbit the Alpha Centauri stars? Unlocking that secret is mind-bogglingly hard. Hunting down these hidden exoplanets ranks among the absolute toughest puzzles in all of modern space science. Why? Because worlds like ours do not shine. They are cosmic specks, completely swallowed up by the blinding brilliance of their host suns. Picture trying to spot a single blinking firefly dancing directly in front of a giant stadium floodlight. That is what astronomers are up against. As the years have rolled on, brilliant minds have engineered a few clever tricks to hunt down these invisible worlds. First is the transit technique, which waits for a planet to drift right across the face of its star, triggering a microscopic shadow or dimming effect that we can measure. Then we have the radio velocity trick, sensing the gravitational tug-of-war that makes the star jitter. Yet for our closest neighbor, both of these tools fail us. The shadow-catching transit trick demands absolutely flawless cosmic geometry, and that jitter measuring technique is basically useless here, because Alpha Centauri is actually a twin-sun setup. The two massive stars dance around each other, creating such chaotic gravitational ripples that any tiny planetary tug gets completely erased. Luckily, we have a wild card up our sleeve called direct imaging. Rather than looking for shadows or wobbles, this bold approach attempts to snap a real, literal picture of the alien globe. Pulling this off is next to impossible, considering these rocky bodies glow billions of times weaker than the roaring nuclear infernos they orbit. Plus, from Earth's point of view, the target world is practically hugging that inferno, totally washed out by its intense rays. Yet, human engineering has taken a monumental leap forward. When the James Webb Space Telescope blasted into the cosmos in December 2021, the rules of the game were entirely rewritten. This magnificent eye peers into the universe using infrared vision, spotting the faint heat signatures baking off these distant spheres. By looking for warmth instead of light, these hidden worlds suddenly step out of the shadows. The telescope also packs special masks called coronagraphs, acting like high-tech sunglasses to eclipse the glaring starlight. It is exactly like raising your palm to shield your eyes on a bright summer afternoon. Furthermore, by hovering in the freezing depths of the outer void, its instruments stay cold enough to catch even the weakest whispers of thermal energy. Mixing these groundbreaking tools transforms this observatory into the ultimate, undisputed champion of exoplanet discovery. As the calendar flipped to early 2025, a bold crew of scientists pitched a plan to train this super telescope right at Alpha Centauri A. Because this system is practically in our galactic backyard, any potential worlds would visually fan out much wider from their host sun compared to faraway systems, granting us a cleaner shot at snapping a photo. They locked their sights onto the A star specifically, since its brilliant Earth-sun-like nature makes it the absolute prime suspect for hosting life. This intense staring contest spanned across several weeks, bridging the late spring and early summer of 2025. The Grand Observatory locked its golden mirrors onto Alpha Centauri A, deploying, using its built-in star blocker, the coronagraph, to eclipse that blinding glare, while its heat-sensing eyes hunted for hidden, shadowy worlds. The entire mission was orchestrated with absolute precision. Scientists captured a series of snapshots from subtly shifting angles, literally spinning the massive observatory between each picture. Why? Because this twisting motion is the ultimate lie detector test for spotting true worlds hidden among optical illusions. You see, Fake signals, like light bouncing around inside the lenses or tiny flaws in the camera itself, always turn right along with the machinery. But actual worlds, locked in a cosmic dance around their sun, do not move at all. Imagine tilting your head. The smudges on your glasses turn with you, but the distant mountain stays exactly where it is. By stacking these tilted photographs on top of one another, researchers can easily wash away the mechanical ghosts and leave behind only genuine cosmic treasures. They did not just look at one type of light either. The crew gathered data across a whole rainbow of invisible heat radiation. The James Webb Space Telescope is custom-built to peer through various slices of this thermal spectrum. This matters because every planet broadcasts its own unique cosmic fingerprint, a specific barcode of glowing heat that tells us exactly how hot it is and what its skies are made of. By scanning through these different thermal channels, the scientists could verify if the little speck of light they spotted actually behaved like a living, breathing world. Every single staring contest with the cosmos lasted for several grueling hours. The observatory anchored its gaze onto Alpha Centauri A with jaw-dropping accuracy, balancing the blazing sun perfectly behind the tiny blocking shield without drifting even a fraction of an arcsecond. This rock-solid steadiness comes from the telescope's hyper-advanced targeting computer, a brilliant array of trackers that watch the crosshairs and perform micro-adjustments thousands of times every single second. With the target locked, the heat cameras swallowed millions of tiny light particles during every shot, slowly painting a breathtakingly deep portrait of the stellar neighborhood. However, the vast majority of those incoming light particles were just unwanted splash damage, a fierce stellar glare that managed to bleed past the edges of the blocking shield. Because no matter how advanced your eclipse maker is, you simply cannot wall off a star entirely. A little bit of that fiery brilliance always spills over, washing out the picture and hiding those delicate, whisper-faint planets. Once captured, this ocean of cosmic intelligence began its long journey home, beaming down from the observatory through deep space radio chatter straight into our satellite dishes. What arrived was an absolute mountain of raw code, gigabytes upon gigabytes, documenting the exact drop zone and power level of every single particle of light. Before anyone could actually look at it, this massive digital haul had to run a gauntlet of intense digital scrubbing, transforming pure mathematical chaos into breathtaking, crystal-clear astronomy. This vital cleanup phase strips away the mechanical quirks, leveling out uneven camera sensors, ironing out warped mirrors, and muting the endless static of deep space. It is an agonizingly intricate dance that demands absolute mastery over every single wire and lens on that spacecraft. Now, the space agency does maintain an automated assembly line for this, a powerful computer program that instantly sweeps up the raw observatory files. But the real magic happens when astrophysicists push the limits, writing their own bespoke lines of code specifically engineered to crack open their unique cosmic mysteries. And when it came to staring down Alpha Centauri, this digital cleanup was an absolute nightmare. The target is just so overwhelmingly fierce that, even with the artificial eclipse fully engaged, its sheer, unbridled radiation flooded the cameras, painting a thick, blinding fog over every single inch of the sensor. To find any alien worlds lurking in that brilliant haze, the crew had to mathematically reconstruct that glare and strip it away, pixel by pixel, unveiling the secrets buried in the light. Have you ever wondered what it feels like to stumble upon a cosmic secret? Suddenly, right there within the numbers, a hidden glimmer revealed itself. Once the team finished fine-tuning their sensitive instruments, peeling away the blinding glare of the host star, and painstakingly weaving together snapshots from multiple angles, a tiny speck of light stepped out of the shadows. It was incredibly dim, yet undeniably real. Drifting roughly 400 million miles away from Alpha Centauri A, it sparked a wave of thrilling, yet guarded anticipation among the researchers. They had definitely captured something extraordinary. But they first had to make absolutely sure it wasn't just a digital glitch. So they combed through every single detail. They double-checked that this mysterious spark showed up across several separate photographs captured at entirely different moments. They meticulously proved that its distance from Alpha Centauri A never wavered, even as the massive telescope physically turned. effectively proving this wasn't just a trick of the lenses. To guarantee they hadn't just photographed a distant galaxy or a random star in the background, they cross-referenced their findings with vast galactic maps and deep space records. And guess what? Not a single historical record showed anything existing in that specific pocket of empty space. Next up, they broke down the light's unique signature, studying its glow across various heat-sensing infrared bands, and realized the results perfectly matched a toasty gas giant. Every single characteristic of this faint glimmer pointed toward a massive gaseous world. Its heat signature hinted at a surprisingly cozy environment, likely fueled by the leftover fires of its own chaotic birth, combined with the warmth radiating from its parent sun. When they looked at the light spectrum, essentially the fingerprint of its glow across different colors, they spotted the telltale missing gaps that meant specific chemicals were absorbing the light, precisely matching molecules like methane and water vapor, which are exactly the kind of ingredients you'd expect swirling around in a colossal gas planet. In fact, the amount of light it gave off was pretty much spot on for a world as heavy as Saturn orbiting at that exact distance, provided it was still holding on to the fiery heat from when it first formed. Think of infant worlds, those that are less than 1 billion years young. They run much hotter than ancient worlds because their immense gravity is still crushing them inward, squeezing out massive amounts of energy. Using this powerful combination of glowing heat and chemical fingerprints, the astronomers were able to piece together an educated guess about the planet's overall weight and its scorching climate. By lining up its luminous glow with complex computer simulations of how worlds age over time, the experts calculated it to be roughly as heavy as Saturn, meaning you could pack about 95 Earths inside it. Figuring out its exact thermometer reading was a bit trickier, but the infrared data strongly suggested it was roasting somewhere between 500 and 1000 degrees Kelvin. Now, while that would instantly incinerate a human, it's actually fairly chilly for a gas giant. For comparison, the highest clouds on Jupiter sit around a freezing 125 degrees Kelvin. Saturn's upper layers are even colder, dipping to 95 degrees Kelvin. Yet as you dive deeper into their swirling depths, both of these colossal giants heat up dramatically, with their hidden cores blazing at tens of thousands of degrees. So this potential new neighbor in the Alpha Centauri system, if it truly existed, seemed to be radiating vastly more thermal energy than either Jupiter or Saturn managed to pump out right now. We can explain this extra burst of warmth if the world happens to be much younger or much heavier, still slowly sweating out the intense heat of its violent creation. Take a moment to picture Saturn, the runner-up for the title of largest planet in our own cosmic backyard, an absolutely colossal sphere made mostly of hydrogen and helium, beautifully adorned with those iconic, shimmering rings. But here's the mind-bending part. It doesn't even have a solid ground to stand on. If you were to plummet through Saturn's alien skies, you would plunge through endless layers of gas that grow heavier and thicker by the second, until the crushing weight actually forces that gas to act just like a swirling ocean of liquid. Sink even further down into the abyss, and the unimaginable pressure physically crushes the hydrogen until it transforms into a metallic state, carrying electric currents just like a copper wire. Right at the very heart of the storm, there might be a hidden seed of solid rock and frozen ice. But honestly, it's still one of space's great secrets, because even after decades of peering through telescopes and sending out robotic probes, the true inner workings of these massive gas worlds remain one of the universe's most captivating mysteries. Have you ever wondered what it would be like if a cosmic twin of Saturn was spinning right next door around Alpha Centauri A? Picture a colossal sphere of swirling clouds where you could never actually stand on solid ground, wearing a dazzling halo of shattered space dust and smashed satellites, along with an absolute certainty of hosting a vast family of lunar companions. Our own ringed neighbor boasts more than 80 verified satellites, starting from microscopic fragments all the way up to lumpy, hijacked space rocks and gigantic, perfectly round orbs such as Titan. This massive globe actually dwarfs the planet Mercury, wrapped tightly in a dense blanket of smog, making it the absolute only satellite in our stellar neighborhood possessing a heavy, breathable-looking sky. Just like our homeworld, that thick air is heavily packed with nitrogen, yet it presses down with a suffocating weight, clocking in at 50% more pressure than what we feel at sea level. Down on the ground, the thermometer plunges to a brutal 94 degrees Kelvin, which is so insanely frigid that frozen water behaves like solid granite, while methane flows freely like liquid water, carving out vast alien oceans and rivers. Then there is Enceladus, a much tinier but completely mind-blowing companion. Imagine a pristine shell of ice hiding a massive, dark ocean of liquid water sloshing around deep inside. That hidden sea violently blasts out through colossal ice fractures near the bottom of the globe, shooting towering fountains of frost, water, and the very building blocks of life straight out into the cosmic void. A fraction of that starry snow flutters back down to blanket the crust, while the rest is stolen by gravity to paint one of Saturn's glowing rings. Now, because it possesses that flowing water, those crucial carbon-based chemicals, along with active internal heat, this tiny ice ball stands as one of our absolute best shots at finding alien organisms right here in our stellar backyard. So if that neighboring behemoth is actually out there, imagine the weird and wonderful satellites it might be hoarding. We could be looking at a giant, smog-choked sphere mirroring Titan. Or maybe a cracked, frozen pearl hiding a global ocean, just like Enceladus. These would not just be dead rocks, they would be entirely complex ecosystems floating in the dark. Imagine life harboring realms completely alien to their host star, perhaps even boasting their own tiny satellites, shimmering bands of ice and violent storms, essentially possessing all the majestic traits of a standalone giant. The evidence looked virtually bulletproof, with the researchers exhausting every single diagnostic test imaginable. They meticulously proved this was no random blip or mechanical hiccup hiding inside the observatory's hardware. They also ruled out the sneaky possibility of a distant sun or far-off galaxy playing dress-up as a local world. By cross-referencing a vast stack of photographs captured across various timelines, they proved the mysterious shadow was dancing perfectly in step with its host star, proving an undeniable gravitational tether. Every single piece of the puzzle snapped perfectly into place. When August of 2025 rolled around, they handed over their spectacular data to a prestigious scientific publication, while immediately shouting their triumph to the rest of the world. Normally, getting a seal of approval from the scientific community involves a grueling marathon lasting many months. These manuscripts are tossed to seasoned specialists who rip apart the methodology, interrogate the math, and make absolutely sure the numbers actually back up the wild claims. And when you claim to have found a neighbor right next door in the cosmos, you can bet those experts are going to bring out the biggest magnifying glasses they own. They hunt for the tiniest flaws, picking through every sentence to find any other boring explanation for the data. Yet the astronomers were completely unfazed, knowing they had left absolutely no stone unturned. Their exhaustive mathematical gymnastics showed an incredibly strong, undeniable signature. Because of that rock-solid faith, they skipped the waiting room and broke the news to the public before the ink was even dry on the official review. Believe it or not, this kind of impatient excitement is becoming the new normal in stargazing circles. Massive breakthroughs constantly leak out through early access websites and flashy media bursts, long before the traditional gatekeepers can officially stamp their final approval. Have you ever wondered why massive cosmic breakthroughs hit the internet at light speed? It is because holding back mind-blowing discoveries from months of peer review just does not make sense anymore. Getting the raw data out there means brilliant minds worldwide are able to jump straight into chasing the stars, sparking a global brainstorm before the ink even dries on the official papers. When this particular bombshell dropped, it practically broke the global internet. Picture the boldest headline imaginable. A massive, swirling gas giant spotted dancing around Alpha Centauri, the star system right next door to ours. Every major broadcasting network on Earth became obsessed with the cosmic scoop, breaking down exactly who our stellar neighbor is and why finding a world there changes absolutely everything, while painting epic pictures of humanity's next giant leap. The consensus was clear. We were looking at a monumental pivot in history. Imagine looking up and knowing a colossal sphere of gas is circling Alpha Centauri A, literally a cosmic stone's throw away. The ripple effects of this single observation were staggering. Think about it. Where there is one massive world floating in the dark, an entire cosmic family usually follows. When newborn suns ignite, they are surrounded by swirling disks of cosmic dust and gas, Think of it like a giant spinning pizza dough, and that spinning batter inevitably clumps together to bake not just one, but a whole batch of diverse worlds scattered across the void. Enormous gaseous titans simply do not pop into existence as lonely orphans. If our neighbor has its own version of Saturn, it is highly likely hiding cozy, rocky spheres closer to the sun's warmth. Worlds that might just have the perfect recipe for alien biology. The so-called Goldilocks zone for this specific star stretches from about 7/10 to 1.3 astronomical units out. To put that in perspective, imagine sweeping out a ring that spans all the way from scorching Venus out to the rusty deserts of Mars in our own cosmic backyard. If a rocky sphere happens to orbit inside that sweet spot, you are looking at potential rolling oceans, thick skies, and maybe even something breathing. Suddenly, the brightest engineers at every space agency were huddled over blueprints, dreaming up the first genuine voyage to a foreign star. Ambitious concepts like the Breakthrough Starshot Initiative, a wild plan to blast microchips through the void on laser beams at 20% the speed of light, stopped sounding like a crazy science fiction movie plot and instantly transformed into a viable roadmap, knowing for sure that there are actual destinations waiting for us just next door, completely flipped the script on our destiny among the stars. During an electrifying couple of weeks, the dream of becoming a civilization that hops between solar systems felt real enough to reach out and touch. This neighboring giant was no longer just a blip on a telescope screen or a neat piece of trivia. It became a physical landmark in the galaxy, a concrete shore where human probes might one day wash up. Stargazers immediately began drafting up strategies to lock their lenses onto the target again. The goal was to catch the sphere at various stages of its journey around the sun, pinning down its exact speed and analyzing its cosmic fingerprint. Assuming the Titan takes 2 to 3 Earth years to complete a single lap, watching it patiently for a while would let scientists map out its exact cosmic racetrack. Doing so helps lock down exactly how heavy the world is, and could even expose invisible sibling planets by the way their gravity subtly tugs and pulls at each other, like a cosmic game of tug-of-war. Countless teams of scientists aggressively pitched their cases to get control of the mighty James Webb Space Telescope. Everyone had a unique battle plan for peering into the dark, suggesting distinct thermal light filters and various ways to block out the blinding glare of the host star. A few teams pushed for analyzing the starlight shining through it, splitting those alien rays into a rainbow barcode to figure out exactly what kinds of gases make up its alien skies. Meanwhile, other experts aimed to hunt down icy halos or orbiting moons circling the newfound giant. And plenty of visionaries wanted to widen the lens entirely, sweeping the surrounding blackness for more hidden worlds, hugging closer to the fire or freezing out in the deep. Getting your hands on Webb is no joke. The itinerary is booked completely solid for months, and fighting for a slot is like a scientific gladiator match. Every single year, legions of brilliant astrophysicists throw their ideas into the ring, begging the universe's ultimate camera for anything from a quick afternoon glance to weeks of uninterrupted deep space staring. Ultimately, a council of experts sifts through the mountains of requests, awarding those precious ticking seconds only to the absolute most groundbreaking ideas in modern astronomy. Securing telescope time for Alpha Centauri is usually tough, but these follow-up observations were bumped right to the front of the line. Verifying this new world promised to rewrite our understanding of the cosmos, especially since the discovery was so fresh. But then, the unthinkable happened. Our mysterious new world simply vanished. Fast forward to October of 2025. Just 2 short months after the world first heard the groundbreaking news, a separate crew of stargazers secured the James Webb Space Telescope to take their own look at Alpha Centauri A. Their goal was straightforward: double-check the findings, track this massive sphere as it danced along its orbit, and pin down exactly what it was made of. The James Webb Space Telescope locked onto the star once more, snapping fresh pictures using the exact same high-tech tools and methods. The host star was sitting right where it should be, blazing away as brilliantly as ever. Yet the planet itself? Gone. Staring into the exact pocket of space where a colossal gas giant should be orbiting, yielded absolute emptiness. Not a single blip of infrared light, not a solitary lingering shadow, just total echoing silence in the dark. Baffled, The researchers threw every diagnostic test in the book at their screens. They combed through their data processing steps, double-checked the telescope's tuning, and scoured every square inch of the cosmic neighborhood surrounding the star. Still nothing. By November of 2025, they released a paper detailing their eerie lack of findings. They walked a fine line, making sure not to point fingers or accuse the original researchers of a blunder. Instead, they kept it strictly to the facts, documenting exactly what their lenses captured, or more accurately, the massive void where a planet used to be. The gargantuan world that showed up clearly in May and June had pulled a cosmic disappearing act by October. You can imagine the absolute chaos this unleashed among scientists. The internet practically exploded with wild theories. Astrophysicists clashed on social platforms and deep web message boards, desperately trying to make sense of the illusion. A solid camp of experts stood firmly by the initial discovery, while skeptics raised an eyebrow. The vast majority, though, decided to sit tight and wait, knowing they desperately needed more clues. Online communities dedicated to stargazing were flooded with endless threads dissecting the phantom planet. Science communicators penned massive essays, breaking down the mystery piece by piece. Video creators jumped on the trend, broadcasting the mind-bending controversy to millions of eager space fans. It was not just a science problem anymore. The entire world was captivated, hungering for an explanation to this stellar magic trick. Have you ever wondered how an entire world, the size of Saturn, just deletes itself from existence? That single haunting question became the obsession of every astronomer on Earth. Because here is the thing: planets do not just evaporate. We are talking about colossal behemoths. Picture the sheer weight of 95 Earths, entirely composed of swirling hydrogen and helium, locked tightly in a gravitational embrace. To wrap your head around that scale, 95 Earths clocks in at roughly 60,000 trillion kilograms. That is a weight so incredibly crushing that its own gravity forces it into a perfect sphere, bending the very fabric of space around it. An anchor of reality that large absolutely cannot fade into thin air. To wipe out a world of that magnitude, you would need an apocalyptic, planet-shattering collision. Yet, even if the ultimate cosmic car crash had taken place, the glowing graveyard of shrapnel and dust would blaze brightly in our telescopes for decades to come. Planetary smash-ups are incredibly rare, but when they do occur, they leave behind fireworks that echo through the ages. Take our own moon, for example. 4.5 billion years ago, a renegade world the size of Mars slammed head-on into a young Earth. The sheer kinetic energy melted and vaporized an ocean of solid rock instantly, hurling a massive ring of fire and debris into orbit that eventually glued itself together to form the silvery sphere we see tonight. That was not some silent fade to black. It was a brutally violent cataclysm that permanently scarred both worlds and birthed an entirely new celestial companion. Now, imagine two massive gas giants colliding. The spectacle would be 1,000,000 times more explosive. Those impossibly deep atmospheres of hydrogen and helium would violently compress, igniting into a blinding inferno. Think of it like sparking a miniature sun. The sheer force could actually ignite stellar-level fusion. Such an apocalyptic smash-up would blast out mind-boggling amounts of heat, lighting up our infrared telescopes like a cosmic beacon. The resulting wreckage, a chaotic soup of vaporized rock and stellar dust, alongside the shattered hearts of those doomed worlds, would blossom into a giant, glowing nebula that we could watch expand for hundreds of years. But when we turned our lenses toward Alpha Centauri, absolute silence. Later scans revealed a perfectly peaceful, undisturbed solar system, without a single clue pointing to a recent planetary murder. So how does a whole world just vanish? Researchers quickly threw several fascinating ideas onto the table. Whenever stargazers hit a massive cosmic brick wall like this, they fall back on their most reliable tool. They brainstorm wild theories, smash those ideas against the hard data, and point their lenses back at the dark sky to see which concept survives the trial. That is the beautiful machinery of science at work. It can be a chaotic, fiercely debated process that drags on for decades, yet it never fails to unearth the truth in the end. The easiest and most logical explanation? We simply tricked ourselves, and the planet never existed in the first place. Perhaps that initial glowing dot wasn't an alien world, but merely a glitch in the telescope's hardware. or some incredibly distant star photobombing the exact patch of space right next to Alpha Centauri A, only to drift out of frame by the time we looked again. Seeing ghosts in the machine is an incredibly common headache for space explorers, particularly when you are trying to spot something as dim as a candle sitting right next to a blazing searchlight. If you flip through the archives of space exploration, you will find countless breakthrough discoveries that completely fell apart under a microscope. Sometimes the culprit is just a quirky piece of equipment, a tiny flaw in a mirror, or a digital sensor hiccup that fakes a data spike, tricking brilliant minds into thinking they have found a new celestial body. Other times, a faraway galaxy just happens to perfectly align with our target star, playing the ultimate cosmic optical illusion. And then there are the genuine deep space signals that we completely misunderstand. Think back to the dawn of radio astronomy, when rhythmic pulses from the void were seriously considered to be distress beacons from extraterrestrial empires, long before we understood the physics behind them. In fact, the very first time we heard this rhythmic cosmic heartbeat, back in the 1960s, researchers jokingly named it LGM-1, standing for Little Green Men, until they realized it was actually a dead, spinning stellar corpse known as a neutron star. The hunt for alien Earths has definitely suffered from these mirages too. Throughout the 1980s and early 1990s, multiple research groups loudly celebrated finding new worlds, only to embarrassingly take back their claims later on. Those pioneer planet hunters relied on watching how a star wobbled, assuming the gravitational tug of an unseen companion was yanking it back and forth. However, suns are violent, boiling spheres of plasma with their own chaotic rhythms, expanding and contracting like breathing giants, and erupting with massive storms that perfectly imitate the gravitational pull of a missing world. More than a few supposedly groundbreaking discoveries were just stars throwing temper tantrums, cleverly disguised as orbiting spheres. Burned by these embarrassing blunders, the global network of space scientists grew incredibly paranoid, building an intense, bulletproof checklist that must be completed before anything can officially be called a new world. In our modern era, nobody gets to claim a new exoplanet discovery until entirely separate observatories using completely different technological tricks can all point to the exact same evidence. If you claim to have captured an actual photograph of one, that tiny dot must show up crystal clear across several isolated photo shoots. It absolutely must drift alongside its host sun across the galactic background to prove they are locked in a gravitational dance. And its light signature has to match what we expect from a rocky or gaseous world, proving it is not just some deceptive star shining from the deep abyss. Have you ever wondered what it truly takes to claim the discovery of a new world? Well, the initial glimpses of this potential planet orbiting our cosmic neighbor, Alpha Centauri, checked every single box perfectly, which gave the researchers total confidence to shout their monumental breakthrough from the scientific rooftops. So when critics later suggested they were just chasing a cosmic mirage, the original discoverers fiercely stood their ground. They had not simply rushed to press. These scientists had combed through their findings with surgical precision. They hunted relentlessly for any telescope glitches, meticulously ensuring the mysterious speck of light was dancing right in step with its host star, and proved beyond a doubt that some distant photobombing galaxy was not tricking them. Their toolkit consisted of the exact same tried and true methods responsible for unveiling countless other alien worlds across our vast galaxy. Long before handing it over to journal publishers, the team subjected themselves to a brutal internal audit, deliberately splitting up to have completely separate groups within their own laboratory. Crunch the exact same numbers in isolation just to guarantee every path led straight to the identical planetary conclusion. Now, chasing phantoms is a known hazard in stargazing, but those cosmic illusions usually vanish well before anyone prints a headline. The scientific gauntlet. From brutal laboratory meetings to anonymous critiques by rival astronomers, acts like a massive, unforgiving net built specifically to trap human errors and optical illusions. Flimsy claims or questionable blips almost always get shredded in this rigorous machinery right out of the gate. The simple reality that this astonishing signal from the Alpha Centauri system actually survived the gauntlet and hit the printing presses meant these researchers had absolutely done their homework. What is more, most everyday space discoveries boast only a fraction of the raw mathematical proof holding up this particular alien world. They clocked this monumental find at a massive certainty level known as 5 sigma, which beautifully translates to the chances of it being mere background static, sitting at less than 1 in a million. That kind of staggering mathematical certainty is the absolute gold standard, required to announce mind-bending subatomic particles, and it is rapidly becoming the holy grail for astronomers searching the deep heavens too. When you finally hit that magical 5 sigma mark, you are almost never looking at random blips of bad luck masquerading as reality. So if this neighboring world was truly a ghost, the real culprit had to be some fundamental blind spot within the equipment itself, a bizarre optical quirk or stray light leak that somehow slipped entirely under the radar of their rigorous math. But imagine trying to perfectly forge a cosmic masterpiece. What kind of weird telescope glitch could realistically paint a tiny dot of light sitting in the exact right spot, glowing at the precise brightness, and carrying a light signature literally screaming its planetary identity, while showing up clearly across several distinct stargazing sessions even as the telescope physically rotated, only to totally ghost everyone months later? That is an insanely precise and difficult list of behaviors to accidentally fake, and scientists are frankly scratching their heads trying to invent a machine error that clever. But what if we picture the cosmos as a giant, swirling game of hide and seek? A fascinating second theory suggests orbital mechanics were simply playing tricks on us. Maybe this mysterious alien world absolutely exists, but like a runner rounding the far side of a track, it slipped perfectly behind its home sun right as we tried to take a second look. Think of holding up a slightly tilted dinner plate. If the planetary orbit angle's just right compared to our telescopes back on Earth, the planet might routinely swing directly behind Alpha Centauri A, getting utterly swallowed up by the blinding, furious glare of the star. Astronomers actually have a name for this cosmic vanishing act. It is known as an occultation, and it is a breathtaking dance we watch play out all the time right within our own solar neighborhood. Our local planets regularly sweep behind our sun from where we are sitting, dropping entirely off the map for weeks or even months at a time. Take Earth's brilliant but toxic twin Venus, for instance, which roughly every 19 months hits a dramatic phase known as superior conjunction, sailing all the way to the absolute far side of our blazing star. While it is hiding back there during this dramatic alignment, Venus entirely vanishes from our skies because it is practically hugging the sun from our line of sight. That overwhelming solar spotlight completely blinds us to the planet, even though Venus is still happily cruising along its usual path without a single problem. The red planet, Mars, loves to pull the exact same celestial disappearing act. And whenever our dusty neighbor slips behind the solar curtain, Earth suffers a total communication blackout with all our brave little rovers and satellites for weeks on end, since we physically cannot talk to them while the sun blocks the way. The radio chatter we would. Anything beamed toward Mars might skim dangerously close to our star, getting completely swallowed up or deflected by that scorching solar atmosphere. Have you ever wondered if a cosmic vanishing act like this is the real reason why that famous world around Alpha Centauri seemingly blinked out of existence? Imagine if, back in October 2025, the world simply slipped behind its host sun from our earthly point of view. It would become totally cloaked in glare, hiding right there in plain sight. It sounds plausible, right? But the numbers tell a wildly different story. You see, cosmic choreography is an exact science, allowing us to pinpoint celestial bodies with terrifying precision. When astronomers first spotted this object, they noted a gap of roughly 400 million miles, or 2.7 astronomical units, giving us all the clues we need to clock its cosmic year using Kepler's third law. Think of this rule like a universal speed limit. A planet's year squared is directly tied to the cube of its average distance from the blazing furnace it orbits. This foundational piece of the cosmic puzzle was cracked by Johannes Kepler way back in the 1600s by watching our own stellar neighborhood, and it governs every single dancing world out there. Since Alpha Centauri A is practically a twin of our own sun in terms of sheer bulk, any world parked 2.7 astronomical units out would need about 3 to 4 earthly years to complete one lap. That is the hard limit for wrapping up a single journey through the void. Across those 3 to 4 years, the celestial wanderer traces a massive cosmic track covering a staggering 1,700 million miles. Yet, during the tiny 2-month window from the initial sightings in May and June to the October follow-up, only roughly 1/18th of its total planetary year had actually passed. This means our mysterious globe could barely inch forward a fraction of its total journey. We are talking about a microscopic 20 degrees on the grand celestial dial, a totally insignificant hop. The only loophole? If that orbital pathway was sliced completely sideways from Earth's vantage point. Otherwise, a measly 20-degree nudge comes nowhere near enough to duck behind the blinding glare of the host star. Early snapshots caught this world floating comfortably far from the stellar fire, separated by several hundred milliarc seconds. Fast forward through that tiny 20-degree crawl, and the gap remains wide open, meaning telescopes should easily catch it unless it pulled a flawless eclipse maneuver. But to pull off an illusion like that, the track would have to be balanced on a knife's edge, perfectly flat to our eyes, within a couple of degrees. The universe does not stage things just for us. Solar systems are scattered completely at random angles across the dark canvas, betting that any random distant world happens to spin on that exact razor-thin plane is a massive long shot, ringing in at just a few percent. Sure, it is physically possible, but you would be buying a cosmic lottery ticket, hoping the entire setup was magically tilted just right to hide the orb exactly when astronomers went looking again. Let us play devil's advocate and pretend the path was a stretched-out oval, where the globe swings wildly between freezing extremes and blistering close encounters. The equations still break down. Think of an oval racetrack. The speed limit constantly shifts depending on where the driver is. A world hits the gas pedal as it grazes the stellar surface, then slams the brakes as it drifts into the icy outskirts. All perfectly dictated by another one of Kepler's brilliant revelations. Even factoring in this gravitational slingshot effect, there simply was not enough time in 60 days for an object at that distance to sprint completely into the shadows, barring that absurdly perfect sideways tilt. The idea of a stellar game of hide-and-seek demanded a pile of astronomical accidents that stretched believability to the breaking point. The planetary highway had to be angled flawlessly, and the traveler had to hit the exact right mile marker at the precise moment humanity blinked. And have you ever